Angle problems. You're going to see one or two of these on the assignment. You get one on the test for sure, at least one. So, same kind of a deal we had yesterday. We got this 25-foot ladder being pulled away from a house. Let's say the base is being pulled away at 2 feet per second, just like last time. What we're trying to find this time, though, find the rate at which the angle between the ladder and the house is changing when the base is 7 feet from the house. Okay? So that makes this theta, doesn't it? Okay, I don't even really need the y in this case. I could add it, but why? I don't need it. Okay. So, yeah, that's no pun intended. Okay, so what's the information I'm given here? Okay, good. So my snapshot values are what? X equals 7 feet. What else? X dot is what? 2. And what am I trying to find?
Y dot?
No?
No. Theta.
Theta dot.
Yeah.
Right? We want to know at what rate, find the rate at which the angle between the ladder and the house is changing, right? So that's a rate. Okay, so we need to come up with, then, there's our snapshot values. Now we've got to ignore the dots and come up with a parent equation, a static relationship. So what's going to be the relationship here between theta and x?
Opposite over.
Okay, so it's a trig relationship, isn't it? Right? SOHCAHTOA. So we got a right triangle here, and we know that this is the opposite side relative to that angle, and this is the hypotenuse. So we get sine theta equals x over 25, right?
Yeah.
Okay? Okay, so then that's our parent equation. Now, what do we do? Okay, we've got to, now we cannot plug stuff in, right? How come we can't plug things in? Okay, good, because we haven't differentiated yet, right? You can't plug anything in until after you do the derivatives. All right, so we have to differentiate first then. We're just going to implicitly differentiate with respect to what if we want to get dots out of this? No? T, right? We want to know the rates of change with respect to time. Because what is this? Like, look at this. Look at those units there, right? That's 2 feet per second. So we're looking at a rate of change of length over time, right? So we're differentiating with respect to t. What are we going to get from the first term then if I differentiate sine theta? So derivative of sine of hand is cosine times theta dot. Okay? Equals, what's the derivative of x over 25? Okay, do I have to use quotient rule? No. Good. Okay, the 25 on the bottom is just a 1/25. That's a constant, right? So I could think about this, I don't have to write it this way, but I can think about it as being 1/25 x, so I've got a constant times x. Well, what's the derivative of x with respect to t?
X dot.
X dot. So my answer then is just x dot over 25, right? Make sense?
And you don't do anything to the 25 because of the constant?
Because the 25 is a constant, right? So we pull the constants out front and leave them alone. Okay, so we're trying to solve for theta dot. So to isolate theta dot, all I have to do is divide each side by cosine theta, right? Okay. So then I end up with theta dot equals x dot over 25 cosine theta, right? okay? And a cosine theta, now there's a couple ways I can go about this. Okay, there's a couple ways I can do this. And I'm gonna show you what I think is the best way, okay? I could, if I wanted to, the strategy that we've been using in the past, we looked at some other examples where we went back and added some additional values to our snapshots, right? So if I wanna look at this particular frame in the snapshot, could I add a value of theta? I could, right? I could solve for theta. So if x equals 7, in fact, let's go ahead and just draw this snapshot. So I've got, my triangle looks like this. At my snapshot, this is 25, this is 7, and that's theta, right? Agreed? Okay, so you already told me that theta is equal to, or that sine theta equals x over 25, right? Okay. Could I add another side to this triangle if I wanted to?
Yeah.
I could. In fact, we did that yesterday, I think, didn't we? Let's see, that's going to be, it's just 24, isn't it?
Wait, oh. Yes.
Right? So this is a Pythagorean triple. If I use the Pythagorean theorem, I could add in this value 24, right? Okay, so that's one thing I could add. I could add in there y equals 24, right? Okay? Agreed?
Yeah.
Okay. So that's something I could add. I could go back up to this relationship here, and I could, if I wanted to, I could even solve for theta, because x is 7, right? We know from this relationship down here that sine theta is just 7 over 25, right, in our snapshot. So therefore, what's theta? Going back to trig. How do I unlock that theta? Our arc sine, or is that what you guys call it? You call it inverse sine or arc sine? Same thing.
Is that sine to the negative 1?
Yep. Right, so then theta would equal the inverse sine of 7 over 25, right? And that's just a number, that's a calculator number, right? So that's one way I could do this. I could just add the additional snapshot value. I could just add theta equals arc sine 7 over 25, and then I'm done, right? I could put this in my calculator then. Let's just plug this stuff in. I'll show you how this works on the calculator. Okay, so I could then just plug in, if I want to solve for theta dot, I would get x dot, which is 2. Divided by 25 times the cosine of theta, which is just the arc sine of 7/25. Okay? That's just a number, right? That's just a fancy way of saying a number. So then we would go inverse sine of, what was it, 7/25. Close the arc sine, close the cosine, and we get back 1/12.
And that's your answer?
Yeah, that's my answer.
Wow,
Okay, but
that's not an angle?
there's a better way to do this, though.
Yeah.
That's a little bit, seems a little bit complicated, doesn't it? Having to do that arc sine business. Now, yes.
That's not an angle.
Yeah, it is.
1/12 is?
Mm-hmm.
But that's not the
Oh.
answer, is it?
Well, okay, so this is in, probably this is in, what mode are we in?
Radians?
We're in radians. We might want it in degrees. So-
Well, I'm looking at that way, so there's.
No, mine's calculated in degrees and it's still sideways.
Oh, yeah, it's gonna be the same thing.
It doesn't matter.
No, hang on. No, it's not. So if I go back up here, And,
Yeah, just enter again.
No, it's still 112.
Yeah.
okay,
Did we break it? We broke it.
no, we
I
didn't.
thought it's-
Oh, it doesn't matter, because the cosine, we're getting back, it's a number. We're getting back a number, it makes no difference, right? Because the cosine of an angle doesn't give us back an angle, it gives us back a number, right?
Oh, so this is like the rate, not necessarily the angle?
Right, so this is the rate of change of the angle.
Okay,
Yeah.
so it's not the actual.
Right. Okay,
Bless you.
okay, okay, so,
That's what it's looking for. It says,
I was just, I was confused what.
right.
No, you're like, it's just.
Okay, so listen, please. Listen. Okay, so then, there's a better way to do this though, right? Here's the trick. Kind of a trick. We're gonna use what we call a reference triangle. Whenever you do right triangle trig stuff, everything is based on the relationships of the sides in a right triangle, right?
Yeah.
So in our snapshot, when we figured out that y is 24 by using the Pythagorean theorem, that made this simple for us to write any trig function of theta as a simple ratio, right? So sine of theta is 7/25. What's the cosine of theta? 24/25, right? And so then all I would have to do, instead of having to write this as a cosine of an arc sine, which is a little bit cumbersome, I could just replace the cosine of theta. Now that I've added the missing side to my right triangle, I just write cosine theta as what ratio?
24/25.
24/25, yeah. So this just looks like then x dot is 2. We get 25 times cosine theta is 24/25. Well, what's 25 times 24/25?
112.
Yeah, so I get 2/24, which is what?
Wait, so the cosine.
Right, because cosine of theta is adjacent over hypotenuse. Okay?
Okay.
So we don't,
I like that.
that's better, it's definitely better. So let me emphasize that again, we don't have to go back and add theta as another snapshot value because it's going to be a kind of a cumbersome snapshot value. Instead, what we do when we're dealing with a right triangle relationship like that is we can always just add the missing side to the triangle, so we're going to add y instead. But then we've got all three sides of the right triangle, so I can write any of the 6 trig functions of theta as a ratio of 2 sides. It's just a fraction.
It doesn't turn out on the calculator to be 112.
It doesn't turn out to be 112. When you do what?
When you plug that in gradients or degrees. Like I got, not much in when I had degrees. I got.
You mean when you did this, right? When we did that thing?
That came out
No,
as.
that was right, but the green and the red one, like, or like I plugged in the green one, but like put 24, 25. Isn't that 112?
Oh, it came out right.
Yeah. You just didn't probably put it all in parentheses. Yeah. Okay, questions?
Came out right.
Okay.
Yeah.
All right, you know what? There's maybe one more that I think you would really appreciate seeing, maybe.
I think we should do it all together. Because number one was
There's one more we could do.
Okay, let me just pull up the assignment. How about? Because one of these I know is on the assignment.
What was it?
Okay, here we go. How about this guy?
Yeah, that one right there.
Okay, this is a good one.
It's a dang.
So we've got a light shining from the top of a lamppost, 30-foot lamppost. A ball is dropped from the same height from a point 20 feet away from the light. Okay. How fast is the shadow of the ball moving along the ground 1 second later? Okay. So, we're going to need to. This actually involves a little physics equation, right? Okay, it's no big deal. So here's our. They drew a picture for us, right? Now they're saying that x is going to be this distance. Let's see, where is x? X is the distance from the light pole. Okay, so this whole, so this distance right here is x, okay? This distance is 30, this distance is 20, and let's call the height of the ball, so this distance right here we'll call y.
It's dropped by the same.
Yeah, it's dropped from 30 feet, it's dropped from the same height
Oh, you just
as,
mean inside the triangle.
say it again?
You just mean inside the triangle.
Right, well, I mean, the height of the ball is gonna change as it drops, right?
Yeah, no, I was just meaning like, we put y and I was thinking you meant like the starting height.
Oh, no, right, so that's, I'm gonna leave that as 30 because that's a constant, okay? So let's maybe write that on here, so this distance right here we'll call 30. Okay, so now, it gives us an equation here, right? It tells us that the ball falls a distance, s, which is equal to 16t squared. So really, this distance, they're giving us this distance right here and calling that s, or we can calculate that, right? So after 1 second, how far has the ball fallen? If s equals 16t squared, when t equals 1 second, s would equal 16 times 1 squared, which is what? 16. Okay, so s, so now we can plug in a bunch of things now, right? We've got a bunch of snapshot values. We could do one other thing. We know that if s is equal to 16t squared, what is y equal to?
Can we just break this up to writing?
Sure.
So writing the words.
It didn't write from 30 minus,
Okay, I heard it.
30 minus 60.
30 minus s is y, isn't it, right?
Yeah.
So we could write y as
Oh.
30 minus 16t squared, right?
Yeah, how do you know?
Because this whole distance is 30, right? And so if that's s, 30 minus s would be y,
Equals y.
Okay. right?
So, but there's no s in that equation, so why talk about it?
Well, okay, so-
Okay, gotcha.
Yeah, so s is up here. But really what we're doing, if we look at this, would you agree, I mean, kind of the picture that we're interested in probably has to do with these triangles down here, not so much s, right? So we're taking that information they gave us about s, and we're gonna use that to come up with an expression for y, which is more valuable to us, right? So y is 30 minus 16t squared. So at s, or t equals 1, y would just be 14, wouldn't it? Right?
Sure.
Right, so if we wrote down our snapshot values, we know that snapshot, and this is at t equals 1, right? We know that y equals 14, if s equaled 16, right? 30 minus 16 times 1 squared is just 14,
Okay.
right?
Yeah.
I don't know.
Okay, so the only added wrinkle that they gave us on this one was that instead of them just telling us that, okay, when the ball is 14 feet high, we're having to calculate it from an equation,
But I thought the ball, okay, never mind.
okay?
Getting closer to what.
So there's one snapshot value, y equals 14. We could actually calculate another one though.
X.
Yeah, we probably could. What about though, we're also gonna wanna know the velocity of the ball, right? So the velocity of the ball, or the speed of the ball, is just gonna equal y dot, dy dt, right?
How do we know that?
Okay, we could, because we know that velocity equals the rate of change of position, right?
I do. Yeah.
Okay, we don't even have to call it velocity though, we can just call it y dot. Let's just call it y dot. We don't even have to call it v, we'll just call it y dot. What is y dot equal to? 0
0. Minus 16t.
minus,
I'm confused. Why are you getting these numbers from?
Wait, why is it?
Did you just make that up in your head?
well, no,
Oh, I get you.
Here's why, right?
Yeah.
So if I
Oh.
differentiate y with respect to t,
Yeah.
I get y dot, don't I?
Oh, cause you, oh, I didn't know.
Okay?
You just pull out.
So then at t equals 1, what's our snapshot value for y dot?
Negative 32.
Wow.
Okay, what is it that we're actually looking for here?
X.
Well, no. How fast is the shadow of the ball moving along the ground?
Speed.
Okay, so what is that if we call this variable x?
A.
Acceleration, I don't.
Well, it is a speed, you're right. But in terms of x, what is that? X is the distance of the shadow from the pole. If we're asking the question, how fast is the shadow moving across the ground? Isn't that really the same thing as saying, what's the rate of change of x? Right? X dot, isn't it? Now let's take an example. Would you agree that if x dot were negative 10, right? Negative, they would just be, the units would be feet per second, right? Because x is measured in feet, so x dot would be feet per second. If x dot, the rate of change of x, were negative 10, then isn't that the same thing as saying that the shadow of the ball is moving at negative 10 feet, or 10 feet per second towards the pole?
Yeah.
It's negative because it's getting smaller.
Yeah.
Agreed? Okay. Right? So we're looking for x dot, right?
What, where did
But do we have X?
Yeah.
We don't. Okay, we don't have x, but we could find x, right?
But where did the 10
We don't
come
know.
from?
Okay, I got too many. I got a question here. Please raise your hand. So where did the what come from? The 10?
You said 10. He was just making up what it.
Oh yeah. I was giving an example. Yeah, sorry. I was saying if we knew that x dot were negative 10, then that would mean that x was decreasing at a rate of 10 feet per second, and that would just be the speed at which the shadow is moving across the ground, right? Okay. So now we have to come up with, and we might even add an x to this, we'll see. But we have to come up with some kind of parent equation that's going to allow us to relate x's and y's, it looks like. Okay, well, this is kind of a geometric thing, isn't it? This might help, but if I do, that's a right angle and that's a right angle. So can I come up with, and I know that this distance right here is 20 also, don't I?
Yeah.
This distance
How
is
do you
20.
know that?
Because it gives it to us. It tells us it's 20 feet away from the pole.
Oh, that's good.
Okay, Alex?
If they're both right triangles,
Okay,
they're
they're-
ratio.
Good, they're similar triangles, aren't they?
Yeah.
Right? Everybody see it? So what's the ratio going to be then? I've got the ratio of, there's a bunch of ways I can do this.
2 to 1.
Well, we don't know numerically what it is, but the ratio of like big height to small height would be big base to small base, right?
Like 30 to Y?
Yeah, like 30 to y, good. Okay.
20 to 20.
Okay, so we get something like 30 to y
I don't remember doing this.
equals, actually equals x to, what's this distance going to be right here? If the whole thing is x and that's 20, x minus 20.
Oh, wow. Wait,
Okay.
repeat, please.
Okay?
Can you please repeat your?
Sure. Right? So what did we say? We just said the ratio of big to small equals big to small, because they're similar, right? Okay, listen please.
I'm just confused something about the x minus 20.
Okay, because we have to think of these lengths. 30 to y, this whole thing is x, so the base of the small triangle must be x minus 20. Right? Because that distance is 20. If the whole distance is x and I'm taking away 20 of it, I'm left with x minus 20.
Why is there 20 right there though?
This distance right here
No,
is 20.
the other 20, that's
Oh,
confusing.
They had that, ignore that.
Okay.
That's like saying it was like not 20,000.
Okay, right?
Yes, I get it now.
So then all we've got here is just a ratio, and we're just going to differentiate this ratio to get, right?
Can you cross multiply
Okay, there are some things that maybe, we could,
and then differentiate?
we could.
Okay.
We could cross multiply and then differentiate, which is gonna give us products instead of quotients.
Yep.
But I think that sounds good to me.
Okay, so yeah, we could do some stuff before we differentiate. We could, but we could also just differentiate. Now, one thing we should do though, probably definitely should do here is look at when we take this derivative. If I've got 30 over y, that's going to be kind of hard to differentiate. Not hard, but it's going to be somewhat complicated. That's the same thing as saying 30 y to the negative 1, right? Agreed? I'm going to have to use the chain rule. Wouldn't it be easier if I just had y over 30?
But
What's the derivative of y over 30 with respect to t?
1 over 30 y dot.
Can you just so it's small to big instead of big?
The 1/30th is just a constant then, right? So it'll just be y dot over
Y
30,
dot over 30.
right? Much easier. So what's the moral of that story? What should I probably do with this?
Flip it.
Flip it around, right?
I didn't know you could do that.
Okay, listen, I've got way too much talking. If it's distracting to me, I can only imagine what it's like to you. Just shut up if you're not doing it. Raise your hand, or, okay? There's stuff going on back here, and it's just a constant little murmur, and a lot of it, I've been listening, isn't even about math. So why would you be doing that? That's not good. So let's flip this over. I gotta flip both sides of the fraction though, right? So this one's gonna be y over 30. What do I get over here?
X over 20 over X.
Well, x minus
Oh, yeah.
20 over x. Now that's gonna get a lot better too, because look what happens now. If I break that into two fractions, what do I get?
Oh, X over X.
Yeah, x over x is 1, yeah. Look, so I get y over 30 equals 1 minus 20 over x. Now I do get one, that's a little bit unfortunate, but it's better than the quotient rule, right? So this is gonna become the same thing as 20 x to the minus 1, right?
What?
Oh, okay.
Okay,
No.
okay. Did we have to do that stuff? No, but it made it easier. Just think if I had differentiated this, I would have had to use the chain rule on this side and the quotient rule on this side, right? We don't want to do that.
Wait, I don't need.
Okay? Let me move this up a little bit. How about? Yes.
Why are we doing a couple again? I'm sorry.
Because, okay, what we're trying to do here, we just like before. Let's kind of put this. There's so much like little work that happens to try to, make this easier to differentiate. That sometimes it's easy to lose track of the whole train of thought on the whole problem. What are we really doing here? All we're doing is we've got this picture, right?
Right.
We came up with some snapshot values by using, this little equation here, right?
Okay.
Right. So we said that y is equal to 30 minus 16t squared, right? That's the height of the ball as a function of time, but the time is going to be after 1 second, right, for our snapshot. So then if we plug 1 in, this gives us y equals 14, right? If we differentiate this to get y dot, because that's something that's probably going to be important, this is a related rate problem, right? If we differentiate this, we just got y dot equals negative 32t, right? Because we're differentiating with respect to t. What's t dot? Just 1, isn't it? That's just dt, right? Okay. Now at t equals 1, that just gives us y dot equals negative 32, right? We're trying to find x dot. So then we got to go back up to our picture, and we've got to come up with some parent equation. Now in the past, our parent equation has been typically like Pythagorean theorem, or it was a SOHCAHTOA thing in the last example we did. Well, this time, our parent equation, how do we relate x's and y's? Similar triangles, right? I've got a small and a big triangle, but they're similar. And so I can set up a ratio equation. I could have said, I could have done this differently. I could have said big height to big base equals small height to small base. But what we just did, it's just as easy. We just said big height to small height equals big base to small base. That's fine, that works. So that's what we got right here. So that's our parent equation, right? Our job now is to differentiate the parent equation so we get some dots involved in our differential equation, right? But we looked at this and we said, okay, we could make this a little bit easier though. If we just flip both sides, then I'm gonna get an easier left-hand side to deal with and an easier right-hand side to deal with.
Before flipping sides, could you not split that x over x minus 20? Could you not split that to 1 minus?
No, I can't, because I can't do that because I have a difference on the bottom, so I'm stuck with that.
That's right.
That's why, in general, it's always easier if I have 2 terms on the bottom and 1 term on the top. Flipping it is generally going to be a good thing to do, because then I can split it
Why
if I
can't
need
you
to.
do that?
What's that?
Why can't you do that?
Well, let's look at a numerical example. If I take 5 over 3 minus 2, that's 5, isn't it?
Yep.
Okay. But is 5/3 minus 5/2 equal to 2, or equal to 5?
Probably not.
It's not, right? So, see what I'm saying? You can't do it. It doesn't work. Okay. Oops. Okay, so then now let's differentiate. So what do we get when we differentiate? On the left side,
Y dot over 30.
y dot over 30, good, is equal to
20.
0, right? Minus 20 times, now what's the derivative of negative 20 x to the minus 1?
20x
Times x dot, right? Okay, so that's the same thing as saying 20 over x squared, right? Let's do that. Okay, times x dot. Okay, and what are we trying to solve for? X dot, right?
Yes.
So x dot then is just equal to x squared y, right?
What?
X squared y dot, right?
Y dot, sorry, y dot, because I'm gonna multiply, just gonna multiply each side by x squared over 20
And then divide
to get rid of that, right? Over 600,
Wait,
Mhm.
sorry, the 30 we still.
30 times 20,
Wow.
okay?
Not
Right.
We have y dot.
Yeah, we have white out. We don't have that.
Okay, right, we don't have x, right? But that's okay, we can find x. We can go back up here. We could find x.
X is right there. I see it.
Yeah, you're right, there's an x. Okay, so if we know what y is,
Yeah.
Oh, use the ratio.
We know white out.
Yeah. right there, right? Okay, and in fact, why not even use this one, right? Well, it doesn't matter, I mean, either one's fine. We're just gonna cross multiply. So let's use this guy, right? If we're gonna solve for y, we could take this, I'm gonna go to the other page, because this is getting messy.
And I am. It's getting crazy in here.
Y was 14, right?
How do you, yes.
So that's the same thing as 15/7,
Yeah.
right? We can just make that a 15/7, okay? And now we're just gonna cross multiply, right? If I cross multiply, I get 15x minus 300 equals 7x. So 8x equals 300. So x equals 300/8, which is what?
I'll get you
4, which is gonna be,
37.5.
okay? So x is 37.5. So we can add that to our snapshot variables.
Wait, I have a question.
Yep.
So I had 15/7, but why equals 14?
Uh-oh, did I mess it up?
I said loud, I was like.
Oh, no, wait, now we have to.
Okay, shh. Okay, right?
That's so hard.
It's hard. It's a hard problem.
Did you think that we could have done?
It is done.
Yeah, I do. I really do.
I really don't think I could have.
Yeah,
I didn't even write down.
almost. I mean, we're essentially.
Plug
each other. Okay, stop. Don't get sidetracked. So, I mean, that's kind of there's a lot of stuff going on there, but you gotta think about it in terms of kind of the big picture steps. When we got to that last bit, people were panicking a little bit because we didn't have an X, right? What do we do if we're missing a snapshot value?
You problem
Yeah.
solve.
We go back to the snapshot and try to solve for it, right? So at 1 second, when y was 14, we know there's x is going to have a specific value when y equals 14. Where do we go to find that? Well, we've already done some of the hard work, right? We already knew that this was the parent equation that related y and x, right? So all I have to do is plug in y equals 14 and then just solve that for x, which is what I did, right?
-75.
Okay, so is that what we got? So now when we plug all this stuff in,
Answer equals.
there's our answer, right?
Wait, can you do that?
Now we know everything, right?
You just plug in everything.
Everything.
Look at you. Amen.
What did we say it was? Negative
So x was 37.5 times y dot was negative 32 divided by 600. So that's our answer, whatever that is.
Negative 75.
No, it's not.
It's very exact.
Okay, so what's the rate of change? How fast is the shadow moving?
Negative 75.
It's decreasing.
Okay, right, so it's 70, if we want to answer the question exactly the way it's asked, how fast is the shadow of the ball moving across the ground? Well, not negative, just 75. Right, just 75, the speed is 75.
May I ask you a
Pretty
question?
fast, yeah. Feet per second. Yes. Because you can see there's similar triangles. I mean, it's, now it's easier. Now it's done. Yeah. Yeah.
And are we gonna have a
What's that? Yeah. Yeah. Yes.
So it may or may